E is the midpoint of a median AD of triangle ABC. So let's start off with that aspect of the figure. So what do we have? We have a triangle ABC. Triangle ABC. So that's ABC, and we have AD is a median. So this is a median. What does it mean? BD is equal to DC. So if this is X, this is also X, right? And then we have E is a midpoint of this particular. So this is a midpoint. Okay, so E is a midpoint of AD, right? BE is produced. So we have to extend this line to meet AC at F. So let me redo that. Something like this. So this is F. Okay, yes, we had to figure out the relationship between AF and AC. So they are in the ratio of 1:3. So if this entire thing is 3x, so we have to prove that it is, this part is x. Okay, so how will we do this? Yeah, so we have also this to be the midpoint. So these two lengths are equal. This length is equal to this length. So basically for this we need to draw a line. This is one of the traditional questions actually. So this is a line which is parallel to, say, PF. Okay, so we have this to be, say, M. If this is parallel to this, then how can we figure out the answer? Quite simple actually. Let me start off with a bit of construction. Draw DM parallel to BF. That's it. I guess there's nothing else we should be doing. And now we will write to prove and proof then. So we had to prove that AF is parallel to AC by 3. And now we have the proof. So for this, we will start off with the triangle CFE. In triangle CFP, what do we have? We have DC being equal to BD. Okay, and M is parallel to DM is parallel to FP as DB. D is the midpoint of BC. And what else do we have? And we also have that. So let me write it in a well organized manner. And we have BF parallel to DM. So with this, what can we infer? With this, we can infer that M is midpoint of the third side, FC. This is because of, yes, converse of midpoint theorem. Converse of midpoint theorem. Okay, and so if I call, let MC be equal to, say, X. So this is just like that I wrote. So this I'm calling it as X. Therefore MF will also be equal to X. Again, my diagram might not look like that, but it is so. This is because MC is equal to MF, I guess. So let me write a bit neater. Therefore MF is equal to X as MS midpoint of MC, not MC, sorry, FC. So this also will be X. So similarly, what should I do? One more triangle. So we have this set of Wait, which triangle is that? No, not that. Oh yeah, this. So now I'm considering this triangle. What is that? ADM. So remember, we have quite a few things which are similar to whatever we wrote. We just have to rewrite that. Okay, so we are considering, we need to actually take a picture. It'll be, if not, it'll be difficult. Now we can talk about in triangle ADM. So we have BF parallel to, as we have BF being parallel to DM, and we have F as the midpoint. Oh, no, E as the midpoint of AD. Okay. Therefore, by converse of CPCT, not CPT, what am I telling? Converse of midpoint theorem, we have F as midpoint of AM. Right, guys? So this implies AF is equal to FM, and therefore AF is equal to X. So we just prove that this is also X. Again, we need not write converse of midpoint theorem because we already written a similar answer before this, right? And now from 1, 2, 3, 4, so what do we have? We have 3 and say 2 and 1. So from 1, 2, 3, 4, what do we have? From 1, 2, 3, we have F is equal to X AC, which is equal to AF plus FM plus MC, which is equal to 3x. Therefore, we have AF is equal to AC by 3. That's it. AF is equal to AC by 3. Yeah.